Hey Chem 100 students, this is Dr. Ricardo here. We're going to do a short video on limiting reagent, the concept of limiting reagent using some Lego pieces. So this fits into chapter 8 of your textbook, about halfway through. So what we have is we're going to have a sort of Lego building factory. So the materials that we happen to have on hand are a bunch of blue pieces, a bunch of red pieces, a bunch of black pieces that happen to be a little bit longer, and a bunch of white pieces, okay? And the product that we're going to make is an object that looks like this. So it's going to have a black base from one of these long black pieces. It's going to have a blue one centered in the middle, red one on each side, and a white one going across. So in terms of chemistry, we could think of the blue as nitrogen, that's pretty typical, red as oxygen, black as carbon, and white as hydrogen. So this is going to be a synthesis reaction or a combination reaction where we're going to say that our chemical formula to produce the product, how's that? Okay, I'll go a little bit in for a second. Our chemical formula to produce the product is take a blue piece, a black piece, two reds, and a white to make the product. So in a sense, we've kind of have, let's see, we have a blue, black, two red, we have CHO2N, right? If you put all the pieces together. Okay, but we can just think about them as Lego pieces for now. So the most important concept to realize is there's a big difference between what the recipe calls for and what you happen to have on hand, right? So these amounts that I start with can be anything. You know, as the teacher, I can tell you, you can still do this problem if you have 100 black pieces instead of 3, or you just had instead of 4, or you had 50 blues instead of the amount that are here. Doesn't matter. The teacher can put any amount in. What doesn't change, what has to be the same, is the balanced chemical reaction, what you're trying to make. How many of each piece go together to make the final product? So we're not going to count this one as one of our products. This is just going to be our reference so we know how to make them. Okay? So the idea of a limiting reagent question is when all of the different materials that you have, or most of the materials that you have a limited quantity of them. So there's one material, usually, that you're going to run out of first. And the one that you run out of first stops the factory, and you can no longer make any more of the product once you run out of that one material. So the amounts that are left over of all of the other materials can be easily calculated. How much of the product material can be easily calculated? Doing something called a limiting reagent stoichiometry question. So first I'm going to do the experiment for you. I don't know how many we can make. I didn't think about it yet. I just grabbed some Lego pieces from an old Lego box that I have at home. Okay. So first we're going to do the experiment. And then I'm going to show you, based on the amount of starting materials of each, how you could easily go through the calculation. And the key is, it's all going to be related to the amounts of each coefficient in the balanced chemical equation. So let's just quickly take a look at what those coefficients are. This is a 1 to 1 to 2 to 1 to 1 reaction. And I can relate this to this is a 1-to-1 relationship. This to this is a 1-to-1 relationship. This one to this one is 1 to 2. This one to this one is 2 to 1. This one to the product is 2 to 1. I always pick asking questions about how many of these must go with how many of these. So that comes from the balanced chemical reaction, just like the section that we did before. The second thing that's critical before we start is that you realize that the limiting reactant, what's important about it is not which one is in the smallest number based on the number of grams or by the volume, which would be milliliters. It's the one that's in the limit, the smallest stoichiometric amount based on counting them up. So either talking about how many molecules, atoms you have, or something that's directly proportional, which is moles, right? Moles is just counting up the particles. Every time you get 6.02 times 10 to the 23rd of an object together, you have 1 mole of it. So basically, you could think of this as, instead of 5 pieces of blue, you could say maybe each one represents a mole. It's a counting number. It counts them up, how many of them there are. Okay? So that's what's going to be important. That's what's going to be related stoichiometrically. Okay, so that being said, let's go into business. So here's the product that I want to make. I want to duplicate that. 1, 2, 3. Put them all together. They're all reacting. Here we go. Take one of these. Put a red on one side. Red on the other side. Go too deep. Leave a space for blue in the middle. Oop, got to move back a little bit. Space for blue in the middle. Put a white one across the top. So far, I've been able to make 1 product. So I'll put the products up here. Right? Those are my final products. Okay, keep going. Right? We know what the model looks like. That was the first one that we were building. Next one. Take my 1 black, red, blue in the middle, other red, white, across the top. I made 2. Take my black. Still not thinking about what the answer is. Put my blue in the middle. Take my red, goes on the other side. Put the white across the top. Not out of business yet. I'm still going. Get that white across the middle. Was able to make 3. Here comes the 4th one. Got my black. Put red on one side. Blue in the middle. Red on the other side. White across the top. I was able to make 4. Which is the limiting reagent? The one that I ran out of? The one that I have nothing left? Well, in my particular case, with all of the materials that I started with, it was the black, which was the carbon. That was the limiting reagent. It's the thing that you run out of first. I still have 1 blue left. I still have 3 reds left. I still have 5 whites left. Okay? They could have been any amounts. These are not necessarily going to be in a stoichiometric amount. Over here, though, I was able to make 5 products. So we figured out 2 things. One was we were able to calculate the amount of products that we can make. The second thing is we were able to figure out which thing we ran out of first. In that case, it was black. And the last piece of the puzzle, how much of each of the other reactants is left over? Well, there's 1 blue left over, 3 reds, and 1, 2, 3, 4, 5 whites left over. Okay, so that being said, let's go back and see if we can get those same ratios, right? I'm going to write them all down on a separate piece of paper, so we'll see if they all agreed. Okay, so when we did the experiment, right? Put this up here for a second. When we did the experiment, how much of each thing did we have to start with? So these will be the starting amounts. Okay, well, go back and count. We have 1, 2, 3, 4. We had 5 blue, which I called B, right? 5B. All right, how many blacks did we have? We had 4 black Legos, which I call BL. 1, 2, 3, 4. So if I counted back what I had at the beginning, how many reds did I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 reds. And how many whites? 1, 2, 3, 4, 5, 6, 7, 8, 9 whites. Okay, so those are the starting amounts. Okay. What did I wind up at the end? After the chemical reaction was over, I wound up with 4 new products, right? That's brand new. Left over, I had 1 blue, which we call B. I had 0 black. That was what we called BL, and that's the special quantity called the limiting reactant. Okay, the limiting reactant is black. Okay, how many reds did I have left over? I had 3 reds. And how many whites did I have left over? Lot 1, 2, 3, 4, 5. Okay, so this is our experimental result. So I'm going to put that on the side. Now we're going to do the type of calculation based on our starting materials and the limiting reaction. Okay, we should be able to get everything that we got on this sheet that I'll have on the side. Okay, so we'll call this experimental. So when we do our limiting reagent calculation, it's got to match up with the experimental. So here's our balanced chemical equation. So let's write out our question. How much product can be made from, go back to our starting materials here, 5 blue, which we're going to call B, 4 black, which we're going to call BL, 11 red, and 9 white Legos. Okay, so now the way I'm going to teach you to do this is first is called the foolproof method. So the foolproof method is simply take the amount of each material that you have in either molecules or moles, okay, and relate them through the balanced equation to figure out how much product you have. So based on the amount of starting material that we're given in the question, how much product can you possibly make? We're going to get several different answers. Okay? Once we get those several different answers of how many product we can make based on the starting amounts, what we'll do is compare them and ask ourselves, what makes the most sense? Should we be picking the biggest of all the answers or the smallest of all the answers? But let's not get there yet. Okay, so first one, let's start with the relationship between the blue, okay, pieces that wind up in the product and how much we start with. So I'm telling you, and I can see it counted up here, 1, 2, 3, 4, 5, that's correct, right? If I have 5 blue, right, well, go to the balanced equation because counting up Lego pieces is just like moles or molecules. It's a stoichiometric quantity. It's directly related to how many particles I have. So if I have 5 blues, for every 1 blue that goes in, I create 1 product. So if blue was the limiting reagent, blues will cancel, and 5 times 1 gives me 5. So I should be able to get 5 products. Okay? So we just did the calculation as though blue was the limiting reagent. Okay? Next. Let's try black. It's the next one up here, and it's the next one listed here. Okay, so based on the question, what the question says, how much did they have on hand? These can be any amounts. It could change this right now from 4 to 40, and you can still do the question. if I have 4 blacks, all right, 4 black Legos, times, what's the relationship between the black Legos? Oh, guys, oh, that was blue, yeah. What is the relationship between the black Legos and the products? This was the blue Legos and the products. Now we're doing the black Legos and the products. It also is 1-to-1. For every 1 black Lego that goes in, I create 1 product. So this is 1 black Lego gives me 1 product. So that's a total of 4 products. The number of black Legos cancels with the number of black Legos. My only unit left is products. Okay, so I have 2 possible answers. Okay, if the black Legos are the limiting reagent, they would be able to create the smallest amount of product. If the blue Legos are the limiting reagent, they'll make the smallest amount of product. So far, I've got 2 answers, 5 and 4. Turns out the correct one is going to be the one that's lowest, because I was never able to make the 5th product. Why? Because I already ran out of black Legos. Okay, so I did 2, got 2 more to do. Let me do the red. Wow, I had a ton of red. So I start with 11 reds. What's the relationship between red and the product? Well, look up here. For every 2 reds that go in, I create only 1 product. From the balanced chemical equation, we have a 2-to-1 relationship. The 2 goes in the denominator because I want it to cancel with the R from the reds. So the reds cancel out. Okay? If the limiting reagent was red, okay, would turn out I'd get 11 divided by 2, I'd have 5.5 products, right? Okay, last one. How about the whites? How many white Legos did I have altogether? Well, it says in the question I had 9 of them. So 9 white Legos times, what's going in here is always the relationship in the balanced chemical equation. Okay, let me get this up a little bit. Right. For every 1 white Lego that I start with, I create 1 product. So right from the balanced chemical equation, 1 white gives me 1 product. If the whites were the limiting reagent, then I would have 9 times 1 divided by 9 would give me 9 products. I have 4 possible answers here. This one is can't be possible, can't be possible, can't be possible. All of the ones bigger than whichever one is the small never happen. Why? Because back here, after you were able to make just 4 products, here they are, after the party was over, didn't matter what else you had of the other materials because you already ran out of black. So our answer that we calculated matches up with the experiment. Okay? I should have used them all up, and my limiting reagent is the one that comes from whichever gave you the small answer. This is the correct answer, and this is the limiting reagent. Sometimes you call it limiting reagent or limiting reactant. It's the chemical reactant that you run out of first. Okay? Nothing was, these other ones are in excess, but they're not in huge excess. There's just a little bit left over, so we had to run through the calculation to figure out which one we would have run out of first. Okay? So that's the idea. That's the first way of thinking about it. There's another way of thinking about it that you can put together a table and determine all of the different amounts. So maybe I'll just finish up by doing that. So the way the table is going to work is we can rewrite our balanced chemical equation across the top, which was black plus blue plus 2 reds plus white is going to make a product. Then we can list what's called the initial amount, how much it, and what we have at the end. Okay. Oh, you know what? Let's put one more column in there. let's go talk about how much does it change by, and then what we have at the end. Okay, so the initial amount was the same ones that came out of the question, right? How many of each were put in the vessel? So those numbers, I can copy them down over here. Those numbers were 5 blue, 5 black, 11 red, 9 white, and I didn't have any products to start with. Okay, so I had more than that. I had 5. I only had 4 blacks, 5 blue. Okay, well, what's the relationship? Right, so those are all the different starting materials that I had. Well, the relationship is that for every one of these that I start with, I'm only going to be able to make one product. These two are in equal quantities when it comes to the balanced chemical equation. So that means I need one of these for every one of these. Well, guess what? I have one extra of here, so I'm going to run out of this one first. Okay? So I'm going to use up, and we already figured that out, that I'm going to use up every bit of the black ones. They're going to change by going down by 4, and at the end, I'm going to have 0 left. Okay? So this column just happens to be the first one listed. This is the one that everything is going to be based on the limiting reactant, the thing that you run out of first. You're always going to use it all up, right? You always use all the limiting reactant up. It's the thing that you run out of first. Okay, let's take a look at what happens now. Now, for every one of these that reacts, one of these must also react. Why? Because it's a one-to-one stoichiometry, right? And counting up Lego pieces is like counting up atoms or moles. It's directly related to how many particles you have. So for every one of these react, one of these must also react. Okay, from that. When I use one of these up, I also use one of these up. Why minus signs? Because they're reactants and I'm using them up. Well, I started with 5. I used 4 of them up to make products. 4 of them up wound up over here. How many are left? 5 minus 4 equals 1. Well, that's exactly what we found. We had no blacks left. We have just 1 blue left. Okay. All right. So according to this, if we did it right, we should have 3 reds left when we do this. Okay. Let's follow the stoichiometry. For every 4 of these that I use, for every 4 blacks that I use up to make my product, I must use twice as many reds, because in the product, for every 1 black, there's twice as many reds. There's 2 reds. So when this guy goes down by 8, this guy has to go down, when this guy goes down by 4, this guy has to go down by 8, because it's in a 1-to-2 relationship. For every one of these that you use up, you use 2 of those. Well, if I started with 11 and I use 8 up, there's only going to be 3 left over. And look at my experiment. I've got 3 red Legos left over. Okay. Okay, let's do the white. So we had 1 of these left over, none of those, 3 of these. Okay. And last, let's check out the white. Well, experimentally, we see that we have 1, 2, 3, 4, 5 whites left over. Let's see if that's the case. Okay, what's the relationship between white and black? For every 1 black Lego that you use, you also use 1 white. So when this goes down by 4, this also goes down by 4. If I start with 9 and it goes down by 4, 9 minus 4 is 5. So the end is just do the math here, just do the subtraction. 4 minus 4 is 0, 5 minus 4 is 1, 11 minus 8 is 3, 9 minus 4 is 5. Okay, what's the relationship for the product? Well, the relationship between the black Legos and the product is, for every 1 product, there's 1 black Lego, right? 1-to-1 stoichiometry. So when this guy goes down by 4, this guy goes up by 4. Why the positive? because it's on the other side of the arrow. You create these, you make these. Okay, I start with 0. It goes up by 4. What do I have at the end? 0 plus 4 is equal to 4. And that's what we saw, right? We wind up with 5 white ones. All along the top is what's left over of each of the groups. And here's the products, right? 1, 2, 3, 4. So you have a choice. You can either do it by the table here, as long as the table is always done not in grams, but in moles or molecules. But again, molecules aren't very practical. So you're going to do the table in moles. So you either do the table, where you keep track of how much you start with, how much it changes, and how much you end up with, or the simpler way to do it, the way most people choose to do it, is if I ask you to calculate which material how much of the product you have left, and you don't know because there are many different choices, you go through each choice and relate the amount of the starting material to the amount of product that you're interested in, get the multiple answers, and then whichever gives you the smallest number is the correct answer. Now, if you have a tie between two things, then it turns out that they both are limiting. You run out of two things at the same time. But in chemistry, that usually doesn't happen. We usually run out of just one thing first. Think about cooking, making peanut butter and jelly sandwiches. If you have 4 pieces of bread and a whole container of jelly and a whole container of peanut butter, you're going to run out of bread before you run out of peanut butter and jelly, unless you put crazy amounts of peanut butter and jelly on your peanut butter sandwiches. But if you have 4 pieces of bread, you're only going to be making 2 peanut butter and jelly sandwiches, and the bread was the limiting reagent, and you're going to be left with a lot of peanut butter and a lot of jelly left over. Okay, so that's this concept of a limiting reagent using Legos. Okay, talk to you soon. Bye.